Since the beginning of time, humans have questioned the origins of the universe. Is it possible that the Big Bang was not the beginning of everything? What if the creation of our cosmos was actually just one of countless Big Bangs? Could new universes still be forming today? These fascinating questions lead us to the theory of chaotic inflation, a hypothesis that has gained new momentum thanks to an unexpected discovery made by the James Webb Space Telescope. But that's not all. Based on the collected data, a team of experts has even reached the surprising conclusion that our universe may have been born from the merger with another universe. A simple question, yet an incredibly complex debate. While the discussion about what existed before the Big Bang may seem unnecessary, not all scientists agree on a definitive answer. For example, the famous Stephen Hawking argued that asking what existed before the Big Bang was meaningless, comparing it to asking in which direction the North Pole lies. According to his view, time itself began with the Big Bang, and therefore, there was nothing before it. The very laws of physics suggest that the universe could emerge without the need for energy or an external cause. However, other renowned physicists, such as Michio Kaku, argue that something did exist before the Big Bang, and that string theory might even provide us with a detailed vision of this mysterious prior phase. According to this theory, our universe is just one of many bubbles that make up a vast multiverse. If this were true, then the Big Bang might have been the result of the collision or splitting of pre-existing universes. String theory is based on the idea that the fundamental elements of reality are not point-like particles, but tiny one-dimensional strings. This perspective opens the door to an extraordinary vision in which infinite parallel worlds could exist. In other words, the emergence of life in our universe would not have been a mere coincidence, but rather an inevitable consequence of the physical laws governing the multiverse. But how can we know when and how the universe was created? To answer this question, we must go back in time to the 1920s, when astronomers discovered that the most distant galaxies were moving away from us. This led to the formulation of the theory of the expansion of the universe. By studying this expansion backward, scientists identified an extreme starting point, the initial singularity, from which space, time, and matter emerged about 13.8 billion years ago. However, immediately after the Big Bang, the universe underwent a rapid expansion phase known as cosmic inflation. It is estimated that the universe expanded by a factor between 10^30 and 10^100 in an incredibly short time. Yet, the causes and implications of this extreme growth remain one of the greatest mysteries in cosmology. Some physicists hypothesize the existence of a special field, called the inflation field, which influenced the initial expansion of the cosmos. Depending on its state, this field might have determined the acceleration or deceleration of inflation. Random quantum fluctuations could have caused the transition from a false vacuum state to a true vacuum state, thus triggering cosmic expansion. But what if inflation never completely stopped? Scientists Paul Steinhardt and Alexander Vilenkin suggested as early as the 1980s that inflation could be an eternal process, continuously generating new bubbles of the universe. If so, our universe would be just a small part of an immense, ever-expanding cosmic foam. Recently, new observations from the James Webb Space Telescope have reignited this debate. The collected data seem to indicate that the universe's expansion is occurring at a faster rate than predicted by standard models. This could suggest the existence of interactions with other universes, perhaps even a merger with a larger mother universe. The implications of this theory are immense. If the universe had indeed merged with another, it could mean that our cosmos inherited physical characteristics and fundamental constants from a previous universe. This could explain some of the anomalies observed in cosmological data and offer new perspectives on the very nature of reality. Moreover, the concept of an ever-expanding multiverse opens new scenarios for the search for extraterrestrial life. If infinite universes exist, then the likelihood of life developing in different forms and conditions increases exponentially. We may not be alone, but rather part of a much larger and more diverse cosmic ecosystem than ever imagined. If this theory were confirmed, it would radically change our understanding of the origin of the cosmos. However, much remains to be discovered. The true enigma of the Big Bang and the origins of the universe might be even deeper than we imagine. Only the future will tell us which theory is the right one. Thank you for following us this far. If this journey through the wonders of the cosmos has fascinated you, We invite you to leave a comment with your thoughts and share this content with anyone who might find it interesting. Every interaction helps spread a passion for astronomy and science. Your support is essential to continue exploring the mysteries of the universe and bringing new fascinating theories to light. If you want to contribute further, consider subscribing, activating notifications, and leaving a like so you don't miss upcoming insights. Every small gesture helps this community grow and brings more high-quality content. Thanks again, and see you on the next cosmic adventure.